Hey everybody, this is Larry. This is the Larry Extra Premium problem for today on May 20th. I haven't done it in a couple of days. I was just busy and also my computer was having issues as I mentioned. But today we'll get an RNG problem of a problem we haven't seen or I haven't done yet to get my money's worth. Let's go. 3023, find pattern in infinity stream 1. You give it a binary array pattern and an object stream of class infinity stream representing a zero indexed infinity stream of bits. Okay, so you could use infinity stream.next, which they give you, stream.next to get 0 to 1. We done the first index, starting index, where the pattern matches the bits read from the stream. Here's the pattern. And the first match is highlighted in the stream 0, 1, 0. Okay, so what do we return? Oh, the first index. Okay. I don't think you can do really this is pretty straightforward. I think there's nothing to misunderstand. There's nothing too complex. You just have to do it, really, right? The key thing to note is, I was thinking that you could do it in a greedy way, but that's not right? Maybe that isn't as easy as I make it out to be. It may not be that hard, but it may not be as easy either. Because for something like this, if you go 1 1, this is good. But if you have 1 1, like let's say you have this pattern, and you're given stream 1 1 1 1 1 1 1 or something like this, right? Then now if you go to 0, then of course this 1 is not going to be good. But then if you just do like 0 1, then actually this is the answer. But if you just do like a naive, like, okay, we're here, and then we're 0 and 1, then that's no bueno, right? So then what is the way that we can think about it then? Because basically, the naive way is just kind of keeping track, and then it'll be 10 to the 5th times p or whatever, right? Like if you do it for the length of the pattern every thing, then it's very naive and easy to do, but maybe that's a little bit too slow, so we have to do a little bit smarter. So then the thing that we have to do is a little bit smarter, as in the whatchamacallit? Sorry. We have to do something smarter, like something with I got caught in a train of thought, but something smarter, like something of like a string matching algorithm, right? Now we're just doing it live, but you still the same thing kind of thing, right? And once you get it along those kind of dot, then you can actually use a lot of these other things, right? And what I mean by that is just that you can use KMP, you can use you can do rolling hash, for example. Of course, that's not deterministic, and you can also use probably the Z function as well, right? Okay, I'm going to use the Z function, but I actually don't. So what I'm going to do is I'm going to use the Z function. I think it's called a Z function. I always forget what it's called, but sorry, I'm trying to get my old code from it. It's my computer's being slow. All right, I just asked ChatGPT instead. Right. Okay, so this is the Z function. Oops. Yeah. Well, good enough, I suppose. We're not going to use it. I just want to use it as an example, right? So the idea behind the Z function, and it is something that's kind of interesting, and I like using it sometimes, not all the time. We can also use rolling hash, but I already know rolling hash, so I'm trying to challenge myself a little bit. And the idea behind the Z function is that it is actually maybe not exactly, but in construction, it is very similar to a lot of suffix tree algorithms, which is why I like to get that practice in. Okay, so for this one, we can't just fit it in here, right? I mean, given a string, so let me go. I mean, I think the thing that if you don't know what I'm talking about, you have to Google Z function. I'm not going to be able to give, I don't know it well enough to be able to teach about it, to be frank. So, but the idea here is that what it does is that for each character in a string, and maybe I'm wrong on this, just to be clear, because this is my understanding of it. For each character in a string, this gives a number that represents the number of overlapping, or like gives a number of characters that matches the prefix, right? So basically here, to kind of convert this example where this is the pattern, we can just put the pattern in front. So then we can just do, and then we could add, usually people add like a pound key or maybe $. I think $sign is actually, well, maybe. But yeah, and then now you can say, because then now you, after the first 4 characters, after the pattern, or the 5th, if you count this as a pattern, then now you match this with this and so forth. And then now what we're looking for is something that matches the first 4 characters, right? So in this case, it should give you 1, 2, 2, 3, 4, I think I want to say, and yeah, and this, I don't know if this is 2 or 1. I don't really know. I don't know if this is with this as the prefix or not. Maybe I'm wrong on this, but yeah, but actually, let me let me get a better understanding of this. Right. Oh yeah, of course the first character is gonna be 12, but and we skip all the way to pound, right? So then it's gonna be 2, 4. Okay, yeah. So I had it I had it the wrong way, which is that it is the starting from this character, the number of things that is the prefix. So that means that here, 1, 1 is going to be 2. So then this is the 2, and then this is 4 because 1, 1, 0, 1, and then this is going to be, this is going to be 1. This is going to be 0. This is going to be 2, 2, 1, right? Oh, I guess I just screwed up the slot here. But yeah, okay. Still learning. So yeah. So then now we can use this because we can just say, okay, well, if we run this string into the Z function, then we're good. However, we're giving a stream and not a Z function, right? So we have to think about how to convert this. And maybe you can't, I don't know. I was just trying to see if I can learn from this. Yeah, maybe you can't, but we can maybe make this an online algorithm or given the stream, right? So okay, so let me, so I'm gonna put this here, right? And then, okay. So then we're trying to, I don't know where to put it. I mean, what I should maybe have is a second screen, but that's besides the point. Okay. So then now we maybe said is equal to set is equal to this. I mean, obviously the thing that we cannot do is we don't have the length, and that's the biggest thing, right? So then now we have left, right, k is equal to 0, 0, 0. We'll try to make this algorithm online. So then we also have maybe I is equal to 0, right? And then while true, if I is greater than right, this is easy to do. Left, right is equal to I. Well, right is, well, right will never be done, so it should just be, so this is always going to be true. So while true, and s of right is equal to, do we want to store everything? Well, I guess we have to some degree, but So then when we increment, what does that mean, right? Increment means that, okay, let's say we have a string. I don't know if this is quite the nice way, because I think in terms of space usage, I didn't realize that this actually does this. But okay, I mean maybe that's fine. It's just, you know, but when we increment, what does that mean? That means that we want to populate something to the s, right? So we append s of, what's it called, stream.next, right? And then now we have z of I, which is also append right minus left, and then now right subtract by 1, right? And then the second half is else k is equal to I minus left. I really should learn the whys of this one, to be honest, but well, f is equal to I, right? So then while again this is true, while s of right is equal to s of right minus left, then here we increment right, which again means that we are appending the stream.next, right? And setting this is also actually should be a z.append. So one day I'll actually learn why this works. Oh, I didn't know that there's gonna be a right. I saw it here, so maybe I'm wrong about it. Maybe I'm wrong about the always streaming thing. Maybe it doesn't have to be. I don't know. I mean that's fine. I mean all we have to do is just add an if statement, really. But it's a little bit. I mean right now it's still correct. It just uses too much work. That's all. Okay. Well, true, but then now, so that means that the last z value should be, if it's not equal to length of pattern, which is p, I think. Okay, so z is 0, 1. Oh, of course, yeah. Wait, is it an of course? What am I talking about? Well, this terminates before. Oh, this is because of this. Okay. Okay, I mean that's fine. What is k? I don't. This would be easy if I understood what this is doing, but nonetheless. Okay. So then the first one is going to go to this, right? It's going to be 0 minus 0, so this is z of 0. Oh, okay. Maybe I just need the initial one. I don't know. Right minus left. I don't know which way this is out of bounds on though. Oh, well, I guess we can start with maybe just one thing, and then we'll see. Still wrong. Why? Because they should have at least one element. Alright, I guess we'll have to do more debugging. That's okay. Okay, so S 0, and then now we go to the second loop. We have S, and of course we don't have enough characters. But oh, because I increments by 1. Maybe we just need to do this then. I don't know. This is quite the best way about it though. I mean, the return value is always 1, so it's not really the right thing. But it also matches the pattern, which is Y, right? Wait, no. I think the way that I'm doing this is very awkward. Or at the very least, it's I think what I need to do is actually so this is, I think this is actually okay-ish, maybe not. But what I need to do is times this by the pattern plus 1, and then S is equal to, I guess, just pattern actually, and then we can do this plus the pound sign like we said, and then now we should be maybe okay. So this will never be 0, and then now, yeah. Okay, maybe. Let's at least kick it off. Okay, I mean, S looks okay. The P, not so good. Oh, not the P, the Z function. Why is that? Okay. Maybe now I don't need this. I don't know if that's true. This is, nope, I do need it. But then now I don't need this. Why is Z not functioning? Did I look at the code? Let me look at my code again for Z function. No, oh, it's because I append stuff to Z, which is no longer true for the first two things. Okay. Right, I mean, this is going to give me an out of bounds, but let me do it this way, and then we'll I mean, I need a helper function is what I need to do. It's gonna be out of bounds. Yep, okay. Then what I need to do is make just helper function. Like that. Right. Okay. We still only set it to 0, so this is no good. Is that true? Yeah, oh. Actually, oh, okay. But then why does it not give me the... Oh, because I print before. But no, that's not true though. So it does terminate. But here it doesn't even make sense. Oh, well, maybe it does. Because I actually need to know what I is. Oh, Because right keeps going, but then maybe my logic is wrong. This is a very silly day. I'm just doing something that I'm really not familiar with. I is 7, okay. So yeah, so we set, and then now the last item is 2. That doesn't even make sense. It should really be on 5. Oh no, 7 is right, because I counted this from 5, but 7 should be 0, 1, 2, 3, 4, 5, 6, 7. Okay, so then now we return I minus p? No. Why do I have 7? Oh, okay. I minus p is going to be... Well, okay, so we have to minus p again, minus 1 for the prefix and to get to the first thing. Right? Oh, maybe not the minus 1. Because maybe that's counted. Because, oh, well, now it's minus p minus 1 and then 2 of them cancels out or something. Okay. I don't think... am I confident? No. Am I going to YOLO? Well, let's test the other ones first. I forgot. Okay. So I'm glad I didn't YOLO, but... So this isn't even that right, to be honest. So it's not good enough. Why? Okay, so this is the pattern. Oh no, this is not the pattern. This is the pattern. So this should be, and this thinks is 8, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, which is right. So it's this one. So we want to minus p plus 1, which is this, and then minus p minus 1 to get to the first index, right? Oh. No, that's why. Oh, wait. Oh, wait. No, this is just wrong. I did it wrong. Why is it 8 though? 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, no, that's wrong. Why? 0, 1, 0, 1, 0, 1, 0, 4. Where is it? So it's not dependent on I, is it? 4, 5, 6. Well, it's I minus 1 because we added an extra 1, I guess. But so it's 7. 0, 1, 2, 3, 4, 5, 6, 7. I mean, this is the right index. So is it just I minus 1? Am I just being dumb? Well, I'm minus p. I mean, it's something like this, but I feel like I'm mucking it up a little bit. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. So this is the right index, right? So I is right. So we want to subtract 5. Right? So it's... Oh, because I have a plus 1, so I have to do my... this is such an awkward thing I'm doing. I mean, I guess I could have done like an if statement out here. Because there was 2 minus 1s and I kind of conflated them a little bit. One of them is for this one and the other one is for the extra this thing. So okay, let's give it a quick submit. We'll see if it works. This is not super space efficient, so we'll see if that bites us. And maybe we get an infinite loop because I don't know, this feels sketch, but okay, so it's good enough. Yeah. And basically we do a little bit more, but that's fine. I mean, and we can actually make that as an if statement anyway. So like, you know, if, but that only saves up to like 100 characters, right? Basically the idea here is that if we need s sub I next, then we do it. But yeah, otherwise this is the z function. Yeah, so this is going to be linear time, linear space. That part I'm not super happy about, to be honest. And if I knew a little bit more, maybe we could have kind of reused some space, but I think that's a little bit complicated for me. I don't know. That's all I have though. Let me know what you think. It's a little bit sketch, but like I said, I'm learning, so I feel like that was pretty educational for me. Thanks for watching. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye bye.